This is a small homemade telescope. Not very powerful, but enough for its size. But this is the world's most powerful telescope. Hello everybody, my name is Abhay Kumar and this is AY. And this telescope I just showed you is called the James Webb Space Telescope. And it's the most powerful telescope in the world. The stylish, magnificent and humongous James Webb Telescope. Order yours now today by texting space to 55555. This telescope is currently in space, and in this video I want to tell you two things about this telescope: its engineering and its purpose. So let's go back in time, when the universe just formed. When the universe was in a very early stage, it only had hot plasma. At around 380,000 years, there were only large clouds of hydrogen. Slowly these clouds collapsed and formed the first stars and subsequently the first galaxies of the universe. Light from these stars and galaxies started to travel with the age of the universe. At about 10 billion years, on a blue planet in a new galaxy far away, life is formed. Creatures from this planet evolved to develop instruments to observe light, called eyes. After a few billion years, a race of curious creatures called humans developed their curiosity so much more than any kind on the planet that they aim to find out about the universe they live in and invent a device called a telescope and point it towards the stars. This is a refracting telescope called the Terrible Telescope. I made this to show how one is useful. A telescope is an instrument that helps us look at distant objects like stars. They have helped us find other galaxies, confirmed the existence of black holes, and even calculated the age of the universe. Technically, the title of this video is inaccurate. Every telescope can see the past. In fact, you see the past every time you look at stars and galaxies, as they are so far away that light has to travel for centuries to millenniums, and what you actually see is what the star would have looked like when the light started to travel from it, than what it is now. There's a chance that the star you are observing does not even exist anymore. A refracting telescope like this one uses lenses to observe light from distant objects and focuses it, enabling it to be seen by the human eye, giving a much magnified version of the object. Another type of one is called a reflector telescope, which uses mirrors to give much clearer image of the object. An example of these is this guy, the Hubble Space Telescope. But both of these telescopes have one problem. See, light is an electromagnetic wave, and a wave has two major identities: its frequency, that is the number of waves that pass a fixed point in a given amount of time, and its wavelength, that is the distance from one crest to another of a wave. This is an electromagnetic spectrum. It is the entire range in which light exists. It has radio waves on one side with low frequency and large wavelength, and X-rays on the other side with high frequency and small wavelength. And between all this range, visible light exists, which is the light we can see. But the problem with the universe is that it's playing catch me if you can with our curiosity. I've talked about it before, but the universe is expanding and has been expanding since its inception. So when light travels from far away objects for distances of millions of light years, because of this expansion of the universe, the light from these stars gets elongated. The wavelength of the light increases and frequency shifts to a lower region. This is called redshifting, named so cause red has lower frequency. And this is where the capability of reflector and refractor telescopes lack. They can only observe visible light, hence so much of the information the universe throws our way becomes undetectable to us with these. So instead, infrared telescopes are used to detect the light, as most of it enters in the infrared section of the electromagnetic spectrum. Hubble Space Telescope has some infrared and ultraviolet capabilities, but majorly it works in the visible spectrum. So the discussion for the James Webb Telescope started in the 1990s to be able to overcome this problem. James Webb Space Telescope is one of the most complex things ever built by humans. It took some of the finest brains on this planet 30 years and $10 billion to build this thing. As you can see, this beast does not look like any regular telescope. This is cause it is something called a 3-mirror anastigmat telescope. So it has 3 mirrors. The first one is the primary mirror. which acts as a giant bucket for light from space to be captured in. This is made of 18 hexagonal beryllium gold-plated mirrors. 18 because the mirror is big, hexagonal so it can be joined and transformed easily. Beryllium because it is light and stiff, even in extreme cold. And gold plated because gold has exceptionally high reflectivity at infrared wavelengths. The light from this mirror reflects to the secondary mirrors and then reflects to a third mirror hidden in the center, and then light hits the sensor of the telescope. These visuals maybe can't tell, but this telescope is huge. While the primary mirror is about 6.5 meters in diameter, the whole thing is as big as a tennis court. It's so big that it cannot fit in any rocket as it is. So it needs to be folded and unfolded like a transformer, so it could fit and be launched with a rocket. So where is it placed in space? I have dirt colored skin and I'm wearing blue, so assume I'm Earth. So the Hubble Space Telescope would be right next to me. The moon would be around 100 meters away from me. But the James Webb would be much further than that. It'd be around 400 meters from me. James Webb is about 4 times further from Earth than the moon is. This is because it needs to be away from the light of the sun, Earth and the moon. So for this, the telescope is placed at something called the Lagrange point. Lagrange points are these positions in space near a two massive body system like that of Earth and Sun, where objects face this equilibrium due to the gravitational pull from the two bodies. This is great for spacecraft as it will require much less fuel for them to stay in orbit, as the Sun and Earth do most of that work. There are 5 such points, namely L1 to 5, in the orbital plane of two large bodies. James Webb is currently at the L2 point, where it's slightly orbiting the point, just to not get the solar panels under the shadow of the Earth at all times. And what? Oh, as per you said, extreme cold temperatures. What do you mean by that? Oh yeah, great question. Don't interrupt me again. So as I was saying, this telescope needs to be in extreme cold temperature to avoid temperature fluctuations which would affect its observations. So for this issue, a giant sun shield is put at the bottom side of this telescope. This is a 5-layer sun shield and is made of a material called kapton, with each layer being as thin as human hair. The main observatory is in the cold side, while all the stuff used to keep the telescope in orbit is on the other side, so it could be powered by the solar panels. This protects the observatory from high temperatures. But as the sun rays bounce off this sun shield, it also applies force on the observatory. This is called solar radiation pressure. About 1,000th of a G on a square meter of pressure is applied by the sun rays on the observatory, which doesn't seem a lot, but in 0G it can be a problem. So fuel is used to course correct the telescope, also giving it finite lifetime of 10 to 20 years until the fuel runs out. Now, what are we looking for with James Webb? With this telescope, we're not just focusing on nearby stars. We are focusing on the first stars and galaxies that were formed after the Big Bang. It's a space telescope built to observe some of the hidden mysteries of the universe. Look at this image. This is a picture by Hubble in which you can see these clouds of dust. But if you observe this with infrared sensors, you can see the light from way beyond these clouds. It is similar to thermal cameras, sensing heat signatures that emit infrared light. James Webb can see light from this range. It could observe light of about 0.6 to 28 microns of wavelength and can see way past these nebulous dust and gas clouds that obstruct our way. So comes the most important question of it all. Can we find aliens with this? Will James Webb be able to find aliens? Well, it can though. In another video, I talked about how life can be found on other planets without ever going there. The process is called spectroscopy. Every element absorbs some spectrum of light and transmits the rest. This gives the element a sort of fingerprint. What we basically do is observe the light from the atmosphere of the planet. If we find observations according to some life indicating elements, we can say we may find life on the planet. Till now, no such discovery has proved life on other planets. But with James Webb, we can observe way more planets. But the main objective, or at least one of the major objectives of this telescope, is to observe the early stars and galaxies. So we can find out how we got here, why galaxies formed after the Big Bang, And why is the universe the way it is? Up until now, with Hubble, we can see up till here. But the light from the first stars and galaxies is so redshifted that we cannot observe it outside their infrared range. James Webb can do that. The light from these first stars and galaxies that has now been traveling for 13.5 billion years can finally be observed by a species that built colossal and magnificent instruments just because of the curiosity to see their past and understand their own existence. Thanks a lot for watching, guys, and please subscribe, like and share this video, and I'll see you in the next one, probably from a different location. Till then, take care.